Okay, we live. You can see people in the chat, can you?
If they
Online server members. Authenticated. Yes.
It does show a number of viewers actually.
What's going on, everybody?
It shows the number of viewers in the top left of the embed. If you move your mouse there.
What's that?
In the left.
Oh, here.
You see it?
No way. Where?
No.
Oh yeah.
Okay.
It's weird, like, I can't see anyone on the other end.
Is it mute?
Nah, we're live, I think.
Yeah.
So, yeah, if you're here, just join the chat on the right hand side.
And enter your username on the right side.
Yeah,
of the form.
enter your username.
Just make one up. Going live in 1 minute. Fully. Like
1
starting,
minute, yeah.
Beginning the session.
The month of ML begins in 1 minute. The brutal month of ML. Okay, yeah, I guess if you're here, you're here. Welcome to the month of ML. This is the first session. Yeah, just give us a shout on the chat if you're here. You can put a username in and just, you know, chat on there. Throughout, if you've got any questions or just any comments or anything to say, just throw it in here. That's all good. So, yeah, if you don't know me, I'm Harry, and that's Haroon.
Hello.
And we're going to be running the month of ML. So what is the month of ML? Basically, we are going to do 1 hour live streams every day for the next 30 days. These are going to cover basically everything that we think you need to know to go from really basic knowledge and consolidate that all the way up to being able to run really complex stuff and deploy state-of-the-art models, hopefully to solve real problems. So yeah, the goal is to take you from beginner to, or from wherever you are really, to being able to do state-of-the-art stuff. And we're gonna run sessions every day. That is 7 days a week. 6 of those days are free, and for those who want to go the extra mile, we're running longer, basically workshop style events every Saturday, and these are oriented around deployment. So what we're going to be doing every Saturday is basically focusing on skills that are going to help you to build something real, to actually build something that you can deploy on the internet to serve real users and hopefully solve a problem that you care about. So that costs £10, but we've no doubt that we're here to support you, and if there's anything, if you want to build something, you can, that's minor in terms of what you can make from that, because these are real skills that literally can help you build something to serve real people. So we really want to focus on supporting you guys with whatever you need. So we want to build a community of people who are interested in hacking together software and just creating stuff, sharing their ideas, basically hacking and hustling. If you do those two things, then we want you. And we also want you to go and get more people involved as well. So if you know anyone else who's going to be interested in doing this kind of thing, please tell them that they're welcome to come along, attend all of these late night live streams, which are free. We've done a poll, so we figured out that 9 p.m. is the best time to run these for people. So yeah, basically, if you're here, you can give us a shout on the chat or something. We'll do a shout out or whatever. But it'll be good to know that people are watching, people are listening. If you're stuck at any point, if anything isn't clear, literally anything at all, just put a message in there. I'm here. Probably won't be looking at the chat the whole time, but yeah, if you didn't see, Arun is also here. He's on the chat, and we are here to help get through this. Okay.
Answer any questions.
Yeah, just to answer any questions, and build stuff. So we'll start off with firstly a tour of the website. So you've all seen this. This is the front page. So if you haven't already, you can click sign up, take you to the sign up link. Let us know who you are. We'll be able to keep in contact with you that way. The month of ML, this is where basically everything is going to be for the coming month. So these are all the sessions. Well, these are the first 7 sessions that we've released. We'll probably release the rest tonight, to be honest, but we just threw these up quick. So if you haven't already figured it out, it just works by, put an email there, enter that, it saves it as a variable in the JavaScript, and then you can click to register for an event, and then that makes an API call and saves your name in a list, so that we can get it later, and we'll send you reminders about these events which you're interested in. All right. So if you don't have an email, click there. It'll bring you back up here. It'll tell you if your email's invalid. Yep, that's how that works. So this is the first. This is the first deployment session, which, as we said, will be like a workshop format over several hours, a lot longer than these sessions, and probably more likely in the afternoon. But again, we'll find out when's best for you. So just let us know. And this is linked to, or it will be linked to an event. So let me just get that event. You can sign up for that as well if you want, if you're already interested.
Let's go. Sorry.
Yeah, cool. So there's a link to that. What else is on the website? We're gonna need to know nothing. So okay, office hours. Yeah, if you have any questions or you want like one-on-one support with any question, you've got a deep learning problem, you need help debugging, you just want to chat, whatever. Fill in this deep learning office hours form, and every Sunday we'll have like slots where you can book in a video call to speak to any of us and discuss whatever problems you might be facing. So that's basically introduction to what's happening over the next month and what the hacker hustle is and what we're going to try and help you to do. Again, any questions, put them in the chat. Like, please interact with us. And right now what we're going to do is basically start off with a simple implementation, live coding of reading in and visualizing certain types of data. And then this will obviously build into all the kind of things that you can do with this data, particularly using it to train machine learning models, which we'll show you how to do. So to get to it, I've got this folder here, and it's got some different data types. And it's got a CSV, which is like a spreadsheet. It's got a photo, it's got an audio file, and it's got a video. We're just going to walk through like how to visualize them in code. So I'm here in PyCharm in my editor. We'll just go new Python file here.
Wait,
start here.
Ask how many of them. Show them Colab, so if they want to code along.
Okay, yeah. So if you don't, if you want to code along, and you don't have an environment set up, then you can go to Google Colab, and this is just, this is like it's just an interactive Python coding environment. So you can type whatever you want here, and then Shift Enter to run each cell. It's slow for some reason, probably my internet, but that'll still work. And yeah, you can run all the code that I'm gonna run in there as well. And these are literally just demo files, so you can just type demo CSV, test audio, whatever, and you'll be able to find things like that. Okay, cool. So another thing about what we're gonna be doing over this month is everything is going to be live streamed. Everything is going to be live streamed, but everything is going to be implemented totally live as well. We haven't got any scripts. We haven't got any anything that we're copying from, because we want to show you guys like what it's really like to code something. So when I get stuck, and I will get stuck, I'll have to figure it out. I've got Haroon to help me. Hopefully you guys can help me with any debugging, and I'm just going to look up anything that I don't know, right, and figure it out. So let's start off with, basically, we've got this image, okay? Here's an image, and that's nice for me to see, but it's not nice for an algorithm to work with in that point. What this actually is, right, is firstly, a simple grid, a matrix of pixel intensities, so how much red, green, and blue is in each location in that image. But it's not just a single matrix, it's a stack of 3 matrices. This is an RGB image, which has a red channel, a green channel, and a blue channel. And each of those individual channels are matrices which represent the intensity of that pixel, the blueness, the redness, or the greenness of that pixel. So what this looks like as data is actually a stack of 3 matrices. So that is a tensor. And so we'll see that now. So firstly, we're going to import a library. So we're going to use a library PIL, okay? PIL, Python Image Library. So from PIL, from Python Image Library, we'll import image. And then we can, let's get this file name. Let's get this file name, copy that, go back here, and we're going to say image, so im is equal to image, image.open, I think it is, of that file path. So we'll just print that there, and then we can do im.show, I think. So if I run this, there you go, it pops up. So we've just used this library to open the image. Now, from this data type, which is, as we can see, so if I print its type, what are we going to get? Yeah, so that's of class pil.jpg image plugin. So, I don't want that. So that's cool. I'll just comment this out so we don't get that image keep popping up. But now how does it actually look as a tensor, I said? So let's get it as a tensor, and we'll say, so we're going to import numpy. And this is just a library for working with matrices, tensors, vectors, scalars in Python. So we'll import numpy as np, and then using that library np, we can create an array from this image. Okay, and then we'll print. No, sorry. Yeah, so then we'll print that tensor, okay? And then we'll see what we get. Run that. Now, what is this? Okay, here is the numerical representation of that image. That same image we just converted into a tensor. So let's print the shape of that. So this image, we know, if we run this, this is a 750 by 1000 by 3 channel image. So yeah, like this is this first part here is the red channel, and then I have the green channel, and this last one you can't see where it ends because it's split up, but that'll be the blue channel. So yeah, if that's like that's what an image looks like as data. If there's any questions, again, like just throw it in the chat. And then because this is in a numerical form now, we can start using this with our models. So we'll be able to pass this data to any machine learning algorithms that we create, so they can do something interesting with it, whether that's like detection, computer vision, or whatever, right? So this is a useful format now. When we start using computational frameworks that basically have a load of functionality to make the complex deep learning stuff easy, we'll be using PyTorch, and then we'll actually convert that to a different data type, not a NumPy array, but a torch tensor. So we can say, yeah, we could do that now just to show. So we can import torch. That's going to be the library we're going to be using later, and then we can say torch tensor is equal to torch.tensor of the tensor we have. And then we can print that. And this is the same thing. Forget that. This is the same thing, but this is now, yeah, now this is a torch tensor. And that has some extra functionality that we'll discuss later for making it easy to use in our models. Cool, so we're done with the image. Does anybody have any questions about, like, you know, what else would we like to know about that image? Any requests for me to manipulate it in any way? Just let us know. Okay, and otherwise, what's the next thing we're going to look at? So let's look at this CSV file. If I open this, it's just a spreadsheet, right? So it's got a load of data in. Can't quite. Okay, yeah, it's Florida insurance, something to do with insurance in the state of Florida. And this is the kind of thing like that. Yeah, you can collect in a Google form. You could fill out in Excel, whatever, and you could collect this data yourself. And this is the format it would end up in. But then you want to be able to use that, you know, to do some prediction or to do something interesting with and build some machine learning around. But then again, you need to basically put this in a usable format. So what we're going to do is we're going to take a look at how we can, how can we look at that image, sorry, how can we look at that comma separated value file, that CSV, in code. So we're going to use another library, so I'll start another part down here. This is for the CSV, and all of this is for the image. So for the CSV, we're going to import a library called pandas as PD. So pandas is just a data analysis library, and a main point of it, or really the core thing behind it, is that you can read in these CSV files just like that as something called a panda data frame. So we can do so firstly, let's get that CSV. So let's get that data. We'll say that data is equal to PD, so pandas.read CSV, and then the name of the CSV which we want it to read. So again, I'll just go to here, copy that, Florida Insurance example CSV, it's the name of the file, paste it there, and then we'll print that data. Okay, run that. It comes up in my editor like this, right? So let's say we want to do some kind of numerical analysis on that. So let's say we want these 6 columns here. So from column index 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 8. So let's try and get all of those out and just read them. So let's say, so I don't know how to read that CSV, right? Let's just look it up. So let's say pandas read certain columns, comes up. Let's have a look at this tutorial. Oh no, this is a bit basic. Let's have a look. Indexing and selecting data, reading specific columns, Stack Overflow is always good. So I have a CSV, I want to read some of the columns. Let's say I want column 59 and 60. What can we do? So we could give a list of the fields and then say, so here, when we're reading the CSV, we could just pass in those fields in this keyword argument, use cols fields. But let's say we didn't want to use the name. Let's say we just wanted to use the index. So let's say how to get a column by number in pandas. So that's making a data frame from those numbers and calling the columns A or B. Here's what we're after, right? iLock.
Thing where it shows you tapping, just out of interest. Is that what you put?
I don't think I can show that. Okay. Yeah, so this is what we're looking for, right? This thing iLock here. So iLock means you can locate different parts of the table with the index. So we can say my cols is equal to data dot index using the location, and we want all the rows, right? So we can say colon, that means all the rows, and which columns do we want? We want columns from 3 to 8, and then let's try to print them. Run that. And this is what we were after. Oh, not that. So this is what we were after, right? We've indexed this this data frame from column 3 up to column 8, and we've used all of the columns, all of the rows, and we've got this data out. So yeah, starting with 4,980 498,960. That's up there, all the way down to the bottom of this whole data set. But this is still in a NumPy, sorry, in a pandas data frame form. So this isn't like, even though these are all numbers, it's not like this is a matrix that we could multiply or do some kind of mathematical operation on it. So can we do my array is equal to numpy.array of my cols? Is that going to work? Yeah, cool. Simple as that, right? So we took that, we took this whole data set, we indexed out the cols by the columns by using that index location, got that data. It had all the indexes of the different examples down, and that's not really the data that we care about, that's just the index of the different rows. And it also had the column headings indicating what each of them are. But if we want to use that to do some numerical operations in, then we can convert that to a NumPy array, as simple as that, right? So we just used the NumPy library to convert what we had as a data frame into an array, and now that's something that we could pass to a model, do some conversation on. Anything else I want to mention there?
You could plot some of the variables.
Yeah, let's plot. Let's plot variables. Let's plot that first column. All right. Actually, what looks like a better one? Let's plot. There's not really anything you could plot against.
You can just do a bar chart.
Yeah, I'm not quite sure how to do that. Let's make a. I should have got some better data. Okay, so what are these things? The size limit, site limit.
TIFF 2011 and 2012.
Plot them against each other. Yeah.
You could plot them both. Like in different colors on the same axis.
Okay. Yeah. Cool. All right. So yeah, let's try and explore this data. Let's try and plot these two things in different colors along the same axis. So we'll use a library called matplotlib, and from it a module called pyplot, and then we'll call that plt. It's like the really standard thing to do. Then we'll get get a variable, call it t2011, like this one here. t2011 is equal to, now from my array, so we know that we indexed up to here, right? So this is going to be the last column in our array. That's going to be this here. Yeah, it looks like, so sorry, yeah, I only indexed the 5 columns. I only indexed up to but not including 8. So if I want to get the 8th column as well, then I'll go up to 9. So this is from and including 3 up to but not including 9. So from 3 to 8 basically. Now we're getting those 6 columns, and then when I run it again, this will be a 6. So we'll get from my array, we'll get all the columns, but we'll get the we'll just get the, not the last column, but the second to last column. That's what that negative is there. And we'll say t2012 equal to my array, all of the columns, and then the last, all of the rows and just the last column. And then what we can do is we can do plt.scatter. So using that plotting library from matplotlib, we'll do a scatter plot of t2011. Now you could, let's plot them against each other first, right? So here, like with this editor PyCharm, it prompts the arguments to this function. So it takes in like an x and a y. So what do you want to get? What do you want to plot, and what do you want to plot it against? Vice versa. So let's plot these two things against each other first. Just see what that looks like. Might look like nothing. So we've plotted them with a scatter, and now we can do show, and then that'll show us what that looks like. So to run that, you can see these things are pretty correlated, right? Especially towards the beginning as well. Yeah, so that's how they look there. We might want to try and, I don't know, we could try and do something like predict one given the other. So we can see, yeah, they're pretty evenly correlated, like almost exactly equal along that line x y equals x. But might be able to do something interesting with that later. Anyway, for now, let's instead plot them on the same position. So every position on the x-axis will represent a particular entry in that table. So yeah, it will just be against this index, and we'll plot them on the same axis. So we'll plot 2011 and 2012, but then we'll plot this. So you saw when I ran that last one, they came up as blue points on that scatter plot. Now I think we can just do like second argument, an R for red, and it should show those two different things. I think you have to do color equals red, C equals R. Maybe not. What is that?
No,
What's it?
it's because you're doing a scatter. No, I'm not sure. You have to put np.range in line of that as the first entry.
Yeah, I'm sure it will just be a C equals none.
It needs x and y.
Yeah, I think you're right. It does need x and y. So we will so we want a list there. So we'll just make a new list which goes from which basically contains all the items up to the length of this list. So we'll say that the indexes of this point are so we'll say from the range from 0 by default up to the length of t 2012. This doesn't return a list, it returns you a range, so I don't know if that's going to work there. Run that. Missing positional argument y. Oh, okay. Yeah. So it needs it for both, doesn't it? Run that. Cool. There we go. So, again, if like there's anything that's not clear, anything at all, you can have anonymous usernames if you really want, but otherwise just ask us questions, and we can answer anything that's not clear. Yeah, so you can see for every different individual in this data set, you can compare their blue and red scores for whatever that is. I think it's the difference between something over a year, isn't it? So TIV, whatever that is, from 2011 and 2012. Another thing we could do is we could do 2012 minus 2011, and then run that, and you can see, you know, you could point out people here, like, okay, who's whatever this value is, say it's their income, whose income is increased, and they'll have positive values, and whose is decreased, who's got negative. So yeah, that's some kind of basic exploration of that data there. Anything else exciting we can do?
Change the color of the person.
Okay, yeah, cool. So Haroon says change the color based on whether it's positive or negative. So how could we do that? Well, let's make a variable called the difference, which is going to be t 2012 minus t 2011, and then we'll say what we're going to do. So we're going to need to make 2 scatter plots so that we can give them different colors on the same axis. So we'll make a variable. We'll make one of them called positive, and then one of them called negative. I'll define them in a sec. But we're basically going to do another scatter plot like that. Make that one the negative, and I'm going to say we'll make that one red. And okay, cool. So yeah, we've got the index.
4 million squared.
Okay, so we'll say we can say that positive is equal to diff greater than 0, and then this should return us a binary vector of okay, yeah, let's just print that first. So if we run that, we'll get hold that off for a sec. So we look, this last thing that I printed here was me printing pos. So this last line, true, 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 true. It will have some negatives in there, but basically it's a vector which is filled with Boolean values, either positives or negatives, and where it's positive, that indicates where it's greater than 0. So I could easily do negative is equal to diff less than 0, but probably a better way to do it would be, we can say neg is equal to not diff. I think that's the syntax, right? Not tilde. Yeah, so we'll print neg, run that. Invert not supported for the input types. Okay, I'll do that. Okay, the truth of an array with more than one element is ambiguous, so that's not negating every single one.
No, you need to do diff and then passing that as the argument. Pos.
I need to do what?
You need to do diff and then in like take basically as the indices the pos array. Because that basically gives you ones or zeros as to whether to take that element or not.
Yeah. So if I index the difference with a positive, it'll get me all the positive examples, right?
So yeah. Oh right, yeah. It will give you all the positive examples.
Yeah. So I don't know. Like, the easy thing we can do is just say less than 0. Run that. So here you just see this is the positive vector. This is the negative vector. Okay, so, and you see what you saw happen there. This.
What you should do, Harry, is do diff, and then in brackets, diff is less than 0.
Yeah, we'll do that in a sec. So what you can see here, like what we've plotted, is here we haven't changed this, so we've just scatter plotted the positive. These are the positive indices now. Not the actual values. These aren't the insurance values. These are the indices of it. So so here's like the true value. Here's the false value in those vectors. So now we've got these indices. We can say pos indices is equal to the index. So this index list. We can index that with that binary vector. So where this positive is true, it will get those elements out of the index. And we can say negative indexes is equal to index negative.
Well, you don't need to do that.
Yeah, we do, because we're going to spread it out on the number line, so it needs to be in the right position. Like, so every different entry in that data set is going to be a point along the x-axis. Yeah. and so we'll just put them on those positions. So to get those positions, we need to know what index did they come in the data set, right? So we'll get those indexes, and then here we'll be able to do. So we'll do the x is going to be the positive indexes, and then we actually want the positive values, not just the positive indexes now as well. So positive values is equal to the difference. We're going to index that difference with those positive indices like that, and then we're going to do the same, get the negative values, and we'll get them by getting the difference and taking the difference where getting the differences where that difference is negative. So we found those indexes. These are the negative indexes here. Or this is the Boolean vector of true or false, which we're going to slice this diff with, just to get the negative ones. So we'll do that, and then we should be able to do plot scatter positive indexes and positive values. Copy that, and then just change in this row, positive for negative. Cool. And then run that. See what happens. Only integer scalar arrays can be converted to a scalar index. So what we're trying to do, index here is a range, probably. That's probably the problem. So turn into a list. No, is that a different thing? Only integer scalar arrays can be converted into a scalar index.
You might only be able to do it in NumPy.
Okay.
Yeah.
Let's try.
Yeah, make IDX an NumPy array.
Yeah, let's try that. Cool. There we go. So I don't know. Maybe that would be a useful thing to do in some case, but that's how you could do it if you wanted to. So yeah, that's like just some exploration of that CSV. I hope you're following along, trying to implement this yourself if you care to. Right, now we will move on. We'll comment this out. And then we'll move on to looking at what's the next thing in the list. We looked at the photo. We looked at the CSV. Let's look at the audio. So, how can I... So let's say like I just recorded that audio. I've got no idea how to use it. I want to convert it into some numerical value, right? So let's have a search. Python. What do I want to do? Visualize audio. What is this? Yeah, let's have a look at Librosa, okay? So we're going to import this library, Librosa. I might not have it, so I'll have to install it probably. I can just do pip install Librosa. Meantime, let's have a look what we can do with that. I'm pretty sure I've heard of this as a good Python library for audio, right? So so we can do spectrogram. No. Librosa. Let's have a look at waveform.
Just read it as a MP array and then cut it. Use matplotlib.
Oh yeah, yeah. Okay. Still no library called Librosa. Settings, just add this library to here. Okay, yeah, in the meantime, we can just try and numpy array it. So can I read in a MP4 numpy? Okay, so let's just get that file name. And then how can I read it with NumPy?
It reads it automatically. Just a NumPy array.
Okay.
Or maybe it reads it as a list.
What kind of file? How do I need to open that as a file?
Librosa.load or something.
Okay, cool.
Something like that.
Right, do we have Librosa yet? Or what's happening? Installing. Okay, whilst that's happening, let's look at the video. So, what did we do with the image? We read it with pill. Can we do that with pill as well to read a video? I'm not sure. So let's try and do this equals. You go, how to turn a video into a NumPy array. So, okay, so it looks like we can use that. So CV2, Computer Vision 2 library, I guess, so we'll get this video capture from a file. And then we'll assign these variables using this video capture. From it we'll get the frame height, width and count using other CV2 modules. Not quite sure what that line's doing there. I might have to download computer CV2 as well. I'm not sure it's going to work right now. What?
Should I have it?
No, I just got a new laptop, so I don't know if I've got it.
What's the version?
No, it seems to be working. It's just installing for some reason. Taking a while.
Library for the
Sorry? No. I'll tell you about that later. Let's take. Okay, cool.
There you go, first question.
First question, no way. What's this saying?
It says how do you install how to install it or stuff.
So yeah, how do you install the browser? Like, well, the way I did it was, I guess that's working. Like, you just need to make sure you've got pip set up correctly. So pip is the Python package manager, and you can do pip install that library. With PyCharm, you just go File, Settings, and then you can add it to your interpreter. If you're using PyCharm, then let me know, because I can help with that. Otherwise, yeah, Haroon will give you an answer. So let's have a look at what happens here when I run this. It seems to be working. So there's frame 10. So what was that? So here, we've just shown frame 10 of the video. Okay. So I don't quite know how we're going to get a NumPy array from that, but let's try something else. Video frames in NumPy array. Looks like we've got to use CV2. MP.frame. Okay. This looks more like something that we can use. So let's try and import AV. Not sure I'll have that, but I need to add it as well. So we'll just pip install that AV, and then we'll check out what that library is. So FFmpeg is something which you can use to record and edit videos. So this is just like a Python a binding, so a way to connect FFmpeg into Python. And we're going to use that to open this video, and then what's this container? Packing container. Okay, well this one looks easy, doesn't it? Let's try that. Just get an AV. Do we really want to? No. Let's try this one. Okay, cool. So now we've got this PIMS, whatever that is. Python image sequence. So we're going to read each frame of the video, which is essentially an image, using this library. Okay, so lazy loading, inference, sequential data, NumPy-like slicing. So we'll be able to get that video tensor and then slice it which just means index certain frames of it to get whichever frame we're after. So let's try install this PIMS. Okay, cool. Seems to be working. I've got no red underline, so that's good. Now using PIMS, so PIMS.video, vid equals PIMS.video. What's the video called? It's in the same folder we are. It's called small.mp4. MP4. Okay. And then what we're going to do, then we can just slice the different indexes of it. So if that there, v-1, is getting the last slice of it, well, let's use matplotlib again. Let's use pyplot. Use this line again. So we get that plotting library. And then we'll plt.imshow. So we'll show the image, which was, let's just get a frame first. Let's say frame equals vid 0, so we'll get the first one. Let's print that frame, see what it looks like, because it might not be able to go in here, I'm not sure. Have a look, run that. Okay, seemed to work, so to plt.show, run that. And that is the last frame of this image, of this video, shown using matplotlib there. So now we got the first frame. Let's try. Let's just print the size of that video. See how many frames it has. See if we can find that out. Vid.shape. I don't know if that's going to work here. Image IO reader. Okay, so let's have a look. Here's video. How many frames? We do length. I'll just break that after. So the length is 167. We've got 167 frames in there. So so yeah, let's try and view that video in matplotlib. So we can do for frame index in range the length of the video, so up to the end of the video. Then what we'll do is we'll get these things. Then we'll index the video with that frame index. We don't want to view it, and then we'll show it. I really don't want all of them to pop up. Okay, cool. So it's just showing them one by one. What we can do is so we'll do PLT. So for the plot, we'll turn on interactive mode. So plt.ion, and then so we'll turn on interactive mode. We'll show the plot, and then we'll just keep updating the frames, I guess. No, doesn't like that. Cannot read frame. What's happening? No idea what that is. What do you reckon's happening?
Wait, so does it have a line?
Sorry?
It has a line.
Yeah. So let's just print the index that we get up to. See what's happening. Cool, so it gets up to 166, but it didn't show them, didn't show any of them. So I guess we'll just go up to not the very last index. So because it's got 167 frames, it obviously only goes up to 166 because 0 is the first index, which is obviously 177 of them. So we'll just go up to there. And then we'll plt.show showing that frame, and then we'll do, it's probably going so fast that we're not seeing it, so let's do import time.
There's a PLT pause thing, especially known for.
Oh, is there? plt.pause, did you say? plt.pause. What is that, milliseconds or? Is that milliseconds?
Seconds.
Oh yeah, okay. Cool, so I don't want the range -1, so that range function returns us a range object, and it takes in an integer, so that's where I want the -1. I want to go from the range 0 up to 166. Let's run that. Nothing, it's too slow.
Yeah, 1 second, but no, you should do that.
Oh wait, no, I'm not updating the plot, am I? Yeah. I need to do fig dot, do I need, can I do it without fig? I'm not sure. So we're going to call a function which updates the plot, but to do that, I think what we need to do is not just have a plot, but create a figure. So we'll say plt.figure, and that's just like the object which has the plot on, and then we'll do ax, so we'll make an axis, and then we'll do fig, so on that figure we'll add a subplot in the so number of rows, number of columns, and the index of the subplot 111. Then we'll show the plot, and then we'll do ax.imShow, and then we will and then we'll do fig.canvas .draw. So this one, it just takes the figure, takes the canvas, which is the place where the plot actually is on the graph, and then draws, so it updates whatever we've told it to plot with now. So let's see if this works. Still not looking quite right.
Do 0.1 before we start. 10 per second. So it's 10 frames per second.
No, it's not updating that. I think it actually stays static for a while, but
Do 0.03. That's what it pretty much is from normal video.
Pretty sure it's still not moving. Okay, no it is, there you go. Yeah, it just stays stationary for a bit. So there, we're just showing an image moving, and just like we had earlier with the image, everything on this plot is a tensor right now. So again, 3 matrices. One is the intensity of the red pixels, one is the intensity of the blue, and one is the intensity of the green. That's what's showing up there, and essentially we have a stack of those width by height by channel tensors, and we're just passing them along and showing them on this axis there. So yeah, and then we can obviously we have the NumPy, the tensor form of the image as well when we get that that frame. So that's what we could pass to a model, and we could do that sequentially in some for loop like this to represent the video being passed in. And we'll see like the kind of stuff we can do with that later. So well, over time, but sorry.
Did you have a Librosa?
Yeah, I don't know about Librosa. If this is imported now, we'll do it. Yeah, okay, cool. So we've got Librosa. Let's have a look. Librosa read MP3. I don't know. Load an audio file as a floating point time series. Cool. So we want librosa.core.load. So audio is equal to librosa.core.load, and the path for that is that sample audio. So we'll go here, put that in there, and we'll just break this at the bottom so it doesn't go onto that video section. Okay, let's print the audio, see what that comes out as, run it. Okay, so it looks like that's a NumPy array, the first part, and I guess this is the number of frames, the number of yeah, audio, like data points in that audio stream. So let's and this comes out in a tuple, right? So that's like a bracket with 2 things inside, and the first one is the data. So we'll just get the sorry?
Second one, the sampling rate.
Oh, the second one's the sampling rate. Okay, cool. So what we can do is we should be able to plt.plot. I haven't installed that yet. I haven't got that. So we'll get matplotlib again, and then we'll plt.plot audio the 0 thing. So that was the array inside there, and then we'll plt.show. Run that. There is the audio waveform for this. Yeah, for this MP3 file. So yeah, and that's what it looks like. What else can we do with that? Let's just do.
Plot it.
Sorry.
Did you plot it?
Yeah, I just plotted it. Let's check it out as a MEL spectrogram, and then we'll wrap this up. So Librosa MEL spectrogram. This is like the classic way of viewing data, which shows what does it show? It shows frequency against amplitude against time. Yeah. So it has time on the x-axis, frequency on the y-axis, and then the color indicates the amplitude. So we'll do, yeah, cool, Librosa.feature.mel spectrogram.
Just say now as well, if you have any questions, ask it now.
Yeah.
After the FAQ before we leave.
Yeah, cool. Yeah, if we're gonna do like I know we're over time, but if anybody has any questions like about what the Hacker Hustle is, what the month of ML is, what we've done today, what we're gonna be doing, or anything else, throw them in the chat now. So then we'll just finish this up, and then we can answer them straight away and get on with our night. All right. So yeah, just throw any questions in that chat now. Okay, cool. So what we're going to do, if a MEL spectrogram input S is provided, no, that's not what we want. This is the audio time series Y, so let's just do librosa.feature.MEL spectrogram of the audio. I'm not sure what's going to happen. Is that going to show anything? Close that. Parameter must be of type numpy nd array. So yeah, that was the first thing in that waveform. Okay, cool. Can I like show that? Spec show. That's what we want to get, right? Librosa.feature.MEL spectrogram. Let's have a look. Power to dB. Is that what we want to do? It's a spec show. Yeah, it looks like we can just use that to show the data. So, looks like if we print that, that's the MEL spectrogram data numerically. Is that a numpy array? Let's say MEL is equal to that, and then we'll print type MEL. Let's have a look. So yeah, that's a numpy array, and then we can do librosa.feature.spec. What was this one? Librosa.display.spec show of the audio in position 0. Let's run that. Librosa has no attribute display, does it not? Maybe I need to tuple index out of range, really. Okay, so maybe this actually wants me to pass in the MEL spectrogram. It seemed to work, but it didn't show me anything. What's happening? Okay. Spec show. PLT. Well, it looks like it's putting that on a plot, so let's just copy that and see what happens. Put that there. So we're going to get a subplot. We're going to take our MEL spectrogram, which is the, I don't know, it's probably going to be the
Yeah, how you need to do
MEL.
import librosa.display.
Yeah, I've already done it.
Oh, yeah.
Huh. Oh, we'll do plt.show. That's it. Okay. Why is it so small? There you go. There's well, relatively boring MEL spectrogram, but that's what this looks like. So on the x-axis we've got time, on the y-axis we've got the frequency of the sound, and then the color at each point represents the intensity, so the amplitude of that frequency at that time. So here you can see there's these bright colored ones. That's a loud sound, plus 140 decibels at this frequency. Didn't put any axes on, but I'm sure that's pretty easy to do, and at this time. So yeah, there's now we've gone through all the data types. We've shown how you can get images into numerical form, get numerical data out of comma-separated value files or spreadsheets. We've viewed some videos, and there you can take a look at how to view sound as either a waveform or a spectrogram. So yeah, like that's the first session. That's day one. The month of ML done. So I don't know if there are any questions. Are there? No questions. Okay, cool. Well, you 11 viewers, if you've got any questions, then
there is. I missed the introduction, so could you please talk about making your own dataset event?
Yeah, cool. Is it alright to upload the PyCharm file? Yes, absolutely. So yeah, we're gonna work tonight. So now, okay. Firstly, let me just answer this. Missed the introduction. Yeah, cool. Making your own dataset event. So we're gonna be running live streams every day for a whole month. 6 out of the 7 sessions are free, 1 hour in the evening, just like this one. But then once a week, every Saturday, we're going to hold workshop-like sessions, which are going to be much longer, probably around 4 hours, but depending on the content. And those are basically posed around deployment. So how we can take this code that we're implementing and actually build something from it. So the first one is on making your own data sets, and they'll go on to do things like how to train in the cloud on AWS, how to build web apps, and some other stuff. But basically what the end product of that will be is like you'll be able to take those skills and use them to build something which is really can be valuable. So yeah, the first one is on making your own data set. What we're going to be doing there is introducing you to a bunch of tools which you can use to create structured data from data that you can actually collect. And then we will show you how to make PyTorch data sets from that so that you can load the data effectively into a model which you want to use. So if there's any more questions about that, definitely ask. I don't know if I missed anything there. Anything? That's the deal with that event. That's this Saturday. The link is just up here. So sign up there if you want. We'll put that in. Yeah, we'll put that in. We'll put that somewhere visible on the page as well. Okay, so is it alright to upload the PyCharm file after you're done? Yes, absolutely. So what we'll be doing is, so here's the month of ML page, right? All the content will be populated on this page as we go, but obviously we don't want to have click to register interest here anymore. So after today, what we're going to do is this event is going to stay there, but this button will change to something like view the content, and you'll be able to click that, and it'll take you to a new page which will have both this live stream and a link to probably a GitHub repo of all the code which we've done. So or we'll think of the best way to do it, but yes, the way you'll be able to access it is to just go here and click on this register interest thing. Okay, cool. Yeah, if there's no more questions, I guess that concludes.
As well with some of it.
Yeah, we can send an email out.
Yeah, but you make sure you register so you get it.
Yeah, I don't know if we want to send that to the whole list though.
Oh, okay.
If you want to drop your email here, I can send it to you now. But otherwise, yeah, just watch out for it here. Cool. All right, that's everything we want to do, isn't it? Yeah. Any more questions about just like general stuff about the hacker hustle, or even just like tell us stuff that you want to do. Tell us what you want to learn. Tell us what was good about this session. Tell us what we can improve. Yeah, cool. Feel free to head off and code late into the night or whatever you're up to. We'll hang around for like 5 minutes or something. Yeah. Good session.
So, maybe we should make a button that's always there, and you can always just leave people.
Yeah. Yeah, I actually have that code already written for Adler. I'll put it on the bottom of the page. So I'll just put like a, well, this page sucks, how could it be improved? Just input a form and make that call an API, and then that can email us. Yeah. I don't know, yeah, maybe like if anyone's interested now, I don't know who's here still, we can just show you like how this site actually works. So it's all built using AWS. So basically here is, and AWS is one of the things we'll cover in one of the deployment sessions as well, probably in like 3 weeks from now, 3 or 2 weeks from now. But this is Amazon AWS S3. It's an Amazon Web Service. S3 is, I think, scalable simple storage or secure simple storage or something like that. But basically what it is just you can just make like directories just like I have here. I have my files. You can make them in the cloud. So here is the hackerhustle.com. This and every different like directory you make in S3 is called a bucket. So this is the hackerhustle.com bucket. Here is all of the HTML. Here's like the web page files. So this is the code for that's this page. But you can see the raw of that. I even have it open here. I mean, here's the code I wrote. Yeah, here's, I don't know, that's something else. But here's the Hacker Hustle TV source code for that web page, which you're all watching on now. So yeah, you just put them in here. Got the JavaScript, images, CSS, etc. And you just got to configure this bucket for static website hosting. So you can just click here. You have to set up a few more things anyway, but this basically means that like this is the link to this bucket, and I've got it configured so that it actually takes that data and serves it, well, takes that content and serves it through this URL link, which is how you're viewing it now. So that's all the web page stuff there. What we were implementing earlier was on this page, this kind of more technically interesting. What's happening here is there's some JavaScript on this page, and what's happening is you enter your email here, and then when you press enter, what happens is, so if this email input button is clicked, it runs this function which says which basically it gets the value of the email, and then it sets this the certain the element in the page with this ID tag to saved. So when I press this, it says saved, which means that now it's stored this email, or it's stored the value of what was in this email input field, which is here, as an email variable. And then now when we click register, it changes to registered. And what's happening there is that each of these elements has a register class. I can just show you that as well. Like, oh no, I can't, because I don't worry about that. It has a register class, and then when you click it, if the email is not empty, if it's not null, then it takes the text in this element and changes it to registered, which is what happened there. Then it takes that data. It makes a variable called data, just a dictionary, The first part is the session, so it gets the ID of this element. So if I go in developer tools here, click on this thing, you see it has an ID data preparation. The next one has an ID optimization. So the ID of all those buttons is the name of the session. So when we do this.id, it just gets the ID for that tag and sets that as the session. It gets your email, which you've input there and we've saved as a variable. And then it takes that data and it calls an API, which I've created using Amazon Web Services as well. So that API, what's happening there is basically there's a URL which you can send some data to. You just make a post request, send that data, send that JSON data, JavaScript object data to that API, and then that's another Amazon Web Service, which is this API. It has a method, a function called post, and that is linked to another Lambda function. A Lambda function is another Amazon Web Service. So we can go to Lambda, go to the right region, and then you can see Hacker Hustle register interest. So what this does, and this is written in Python now, so it's nice. So it gets the session name by, it gets the session and the email from those dictionaries, and then it calls this function add to session. And what that does is that goes to my S3, it makes my S3, it gets the object from S3 using the session name, which is session plus the ID of that tag, and then it tries to get what's already in that file, which is in here. It gets what's in that file. I won't open it because it's got people's emails in, but it goes in, it opens that file, it reads it as a string, where it reads it firstly as a string, and then we read it literally to convert it to a list, and then we just add your email to that email, and then put that file back in that same location. And if that file doesn't already exist, it will throw an error, so it will accept it, and then it will make a new item in that bucket. So that's exactly what's happening when you run that web page. And if you want to learn how to do that stuff as well, then just stay tuned. Just stay tuned further for the AWS deployment stuff, because it's really easy, and genuinely with AWS you can build anything. Like you can literally build anything. Cool. So yeah, thank you. We're going to tune out now, and if you like that, same time, same place tomorrow, and Haroon will be running an optimization session.
Peace.
Cool. Yeah, peace out everybody.